In this lesson, we're going to learn about scatter plots and correlation. All right, so our first lesson, bivariate data. Bivariate data is data that has two variables in it. So a list of bivariate data will have values that look like this. So we've got our first data point. It'll have x1, so our first x value, and our first y value. Our second data point will have an x2, our first x point, and our second y point. And the dot 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 just means you can have as many points in between as you want up into your very last data point with an x and a y value. All right, represented graphically, we put them on scatter plots. A scatter plot is basically a dot value with the x value being here and the y value being there, and a dot representing that point. Okay, so we have things that we call the dependent and the independent variable. Now, the independent variable, it's just the variable that we set the intervals of when we'll measure this variable. It's normally found at the top of an axis, and it's normally found on the x-axis. So in this case, we have the price in dollars. This is independent of the number of shirts sold. We've decided to check the number of shirts sold when the price is at these different variables. So the price doesn't depend on the number of shirts. Now the dependent variable, that's the value that we check on based on what we've decided our independent variable will be set as. So we've decided that in this example, when the price of a t-shirt is $14, we'll check how many shirts we've sold at that price. We'll check again if we set a shirt at $18, how many shirts we'll sell at this price. So the number of shirts sold is directly dependent on the price of that shirt. All right, now we're going to look at another example. We've got the number of tickets sold and the total revenue. So the number of tickets sold will be our x-axis, our independent variable, and the total revenue will be our y-axis with our dependent variable. So we make our axes, we have number of tickets sold, x variable, total revenue, and our y. And then we just create dot points. So our first dot point, our x value will be 400. So we look at 400 here. And our total revenue should be 8,000. So 400 and about 8,000, we should create a dot point right about there. Our next dot point, x value of 200, y value of 3,600. So 200 and 3,600 right about here. Okay. Next one, 4,500 and x value. And our y value is 8,500, so about here. Next one, 350 and 7,700, so about here. And so on. So we'll create our other data points, just going along one data point per set of x and y values. And that's how we create a scatter plot. All right, now correlation. Correlation describes the relationship between the two variables, that x and y variable, and we describe it in terms of strength, direction, and form. Okay, so this is the first example we'll look at. In this example, there is a very, very strong linear correlation. Basically, those dot points really look like a straight line. They take the form of a straight line. And we describe it as being positive because as the x-axis is increasing, the y-axis is increasing. So the strength can be described as either weak, moderate, or strong. The form is either considered linear or nonlinear. And the closer the points are to a straight line form, the stronger the linear correlation between the two variables. Now, if the slope is negative, the direction is said to be negative. And if the slope is positive, the direction is said to be positive. So looking at a few examples, we have this one we've already looked at, a strong linear correlation. So the dot points really take on the form of a linear shape, and they're very close to that line. And the x values are increasing as the y values are increasing. Now the next example, we have a weak linear correlation, and it's positive. So as the x values are increasing, so too are the y values. And you can kind of see there is a bit of a form of a straight line, but it's not a very strong one. So you would say this is a weak positive linear correlation. This next one, you can't see a line in there at all. It doesn't take the form of a line at all. So there is no correlation between this x variable and this y variable. A weak negative linear correlation, in this example, you can see there is a slight linear form, but it's not, the dot points don't really line up into a line very well. So we'd say it's weak. And negative because as the x values are increasing, the y values are decreasing. The next one, you can see there is a very distinct linear form, so it's a strong linear correlation. And again, it's negative because as the x values are increasing, the y values are decreasing. The other two now, we've got a strong positive nonlinear correlation and a strong negative nonlinear correlation. So x values increasing, y values increasing means it's positive. X values increasing, y values decreasing means it's negative. And you can see that it is strongly in the shape of something that's nonlinear. So let's do an example. State the type of correlation between the variables x and y shown in the scatter plot. Okay, well, in this case, we've got as the x values are increasing, the y values are increasing, so we know it's positive. And it looks to me that it is very distinctly in the shape of a linear form. So it would be a strong positive linear relationship between that x and the y variable. All right, so now we want to just put it all together. We've got this example where we're comparing the price that we sell a shirt at versus the number of shirts sold. So we've got our independent variable, our x variable, and our dependent variable, our y variable. So to construct a scatter plot, we've got the price, our x variable, set there, and our number of shirts sold, our y variable, our dependent variable, set there. And then we just plot the points. So our first point, 14x and 21y. So 14 and 21 right about here. Next point, 18x, 22y. So 18x and 22y about here. And so on. Our next one will be 21 and 19. 20 and 18. Our next one, 21 and 19. 24 and 17, 25, 17, 28 and 15, 30 and 16, 32 and 14, and 35 and 11. Okay, so now we want to look at the type of correlation between these two variables. Okay, so our example, it looks to me like there is a strong linear form. All those dot points are fairly close to a straight line. And as our x variable is increasing, our y variable is decreasing. So that would therefore mean that the price of a shirt, our x variable, appears to affect the number of shirts sold, and it is more expensive the shirt, the fewer are sold. So as the price of the shirt gets more expensive, the least or the less number of shirts that get sold. And that's how you plot a scatter plot and state its correlation.